What's up, Algebra? It's Mr. Johnson here. We are moving on to some new content here, solving special equations. So these equations don't look much different, but they are a little bit more special than the ones we've been doing. If you look at our learning target, I can solve equations using basic moves. Still same learning target, but slightly different problems. So we're going to jump right into number one and see what happens here. All right, so go ahead and pause this and copy down that equation. So we look at this equation and we are just going to start simplifying both sides before doing any basic moves. So as I distribute my 2, I get 2x minus 14 equals, 5x minus 3x is 2x, negative 17 plus 3 is negative 14. Now I know my next step is to get the variable on one side, trying to keep it positive if I can. So I've got 2x on the left, 2x on the right. Now that's a little bit odd that I have the same amount on both sides. So let's see what happens. I'm going to subtract 2x from both sides. And I'm left with negative 14 on the left, equaling on the right side, negative 14. Well, we know that's true, right? We definitely have a true statement there, and what happened is the variable terms both dropped out of the equation. We were able to subtract that 2x out of both sides. This will occasionally happen in an equation where you are left with a true statement after the variables dropped out of the equation. This means that no matter what I put in for x, x could be any real number and it will work. All right, so what we will say for a solution is instead of 1/2 or -5 or something, we would write all real numbers or any real number. Both of these would be good answers because no matter what x is, I could have x be 5, I could have x be negative 804, x could be 1.973. Any of these x values, if I were to substitute them in wherever I see an x and try this equation out, I would be left with a true statement. So sometimes our equations will have a variable that drops out and we'll be left with a true statement, which means our answer is all real numbers or any real number works. So that's one new instance. Let's look at what another one might look like. Go ahead and copy down this equation. You can pause if you need to. 3 times the quantity x minus 1 equals 3x plus 13. Again, I'm going to distribute 3x minus 3 equals 3x plus 13. Again, I notice the same amount of variable on both sides. So I'm going to follow what I know to do, which is to subtract 3x from both sides. And I'm left with negative 3 equals 13. Now this is a false statement. We know that negative 3 does not equal 13. So again, my variables dropped out from both sides, and I was left with something false. This means that no matter what I put in for x, it will never work. I'll never have a true equation. That tells me that my answer is that there really is no answer. No solution is the answer for this problem because there's no x value that makes this equation true. If I were to substitute x equals 4 in, or x equals 7, or x equals -9, all of these would show false equations at the end. No matter what number I put in, there is no possible solution. So if your variables drop out and you're left with a false statement, our answer is no solution. The last type of new equation, let's see how new this is. We've got our variables dropping out with a true statement is all real numbers. Variables dropping out with a false statement is no solution. And let's see what other types of equations we come across. I'm going to copy down number 3, pause if you need to. As we solve this equation, I'm left with 2x, distribute my -5, minus 5x minus 5 equals -6x minus 2. Combine my like terms here, that's -3x minus 5 equals -6x minus 2. All right, different amounts of the variable on both sides, so this seems to be kind of like our normal equations. I'm going to get the variable on one side by adding 6x to try and keep that variable term positive. -3x plus 6x is 3x. Minus 5 equals -2. I'm going to add 5 to both sides. I get that 3x is equal to 3. I divide both sides by 3 to get down to what x is equal to. I get that x is 1. So we will still have equations that aren't any different than normal. We still get an x value. It's not no solution. It's not all real numbers. It's just 1. 1 is the only value that works for this equation. I were to check, I would let x equal 1, and I would plug it back in for x wherever I see it in the original, and I would get a true statement. All right, so what we need to remember is some equations will just be like this, right? We'll just get an answer, the only one number that works for x. Others, those variables will drop out and we'll be left with a false statement, which means our answer is no solution. And still we will have the variables drop out and be left with a true statement, which means that x could be anything or all real numbers.